Okay, listen carefully here, guys, while we go through this. For question number 1 here, we've got an ionic compound. So if we're going to name that, we don't need any prefixes. This stuff is simply sodium phosphide. No capital letters. Okay, they must have no capital letters in order to get it right. For number 2, okay, we've got a molecular compound because these are both nonmetals. Okay, so this is silicone dibromide. Again, no capital letters. Okay, for number 3, we've got an ionic compound. Okay, and we have ionic compounds we have to swap and drop. That's what the Roman numeral 2 tells us. It tells us that copper is a 2+, okay, and it is combined with nitrate. That is NO3, and it has a charge of -1. So when we drop and swap, we end up with Cu, NO3 in brackets with a 2 outside the brackets. Okay, number 4, molecular compound, diselenium. Okay, so Se triacetatide. So Se2AS3. Sorry, At. All right. That's arsenic, right? Okay, T3, right? All right. So questions on the first 4? Okay. For number 5 here, indicate whether the following compounds are soluble. All right, so you need your solubility chart. Okay. And on your solubility chart, you will find, okay, chlorine is not soluble with silver. Okay, so this is not soluble. Okay, when you look at iodine, okay, it is soluble with most things. And calcium is not in the things it's not soluble with, so this one is soluble. Okay, for copper nitrate, well, essentially all nitrates are soluble. Okay, so that one's soluble. And then chromium sulfide. So you look at sulfide, says it's soluble with group 1, group 2, ammonium, and not soluble with most things. So chromium is right here. It is in group 6. So would that be most things? Yes, it would be. Okay, this is not soluble. All right, so 1 mark each for those. Okay, and then for these, you didn't have to do anything other than identify the type of reaction. Okay, you didn't have to balance, didn't have to write it in words, just identify the type. So on this one here, we've got an ionic compound reacting with an element, forming a new ionic compound, and a new element, that is single replacement for 1 mark. Okay, and this one here has an element reacting with an element to form a compound, which is synthesis. 1 mark. All right, so it's out of 10. No half marks, guys. Give them a mark out of 10. Let them see it. And then please put it in the period 4 box up front here. Okay, so here's what we're going to go over here. We've already talked about balancing. I've kind of already explained how it works to you, okay? But I just want to quickly review how that works. You actually have these notes in your notes package. Just want to quickly go over them. You can highlight a couple things so that you've actually seen the notes package on balancing, okay? And then we'll talk about how we predict the products of a chemical reaction a little bit later. I just want to go over balancing, finish off those worksheets, and I'm hoping that we'll still have a few minutes to start looking at predicting the products of reaction by the end of class after that. All right, so just follow along here. If you've got lesson 14, okay, in your notes, just go there. Okay, so the first thing we got to understand, the amount of atoms on the reactant side, that's the starting side, okay, of an equation must be the same as on the product side. That's the whole reason that we balance. Okay, and the reason that that has to be true is that we have to obey the law of conservation of mass, or the law of conservation of matter, whichever way it's been explained to you. Okay? That says that matter cannot be created and it cannot be destroyed. Right? Therefore, you have to have the same number of everything on both sides of a chemical reaction. All right? Okay. The way we balance a chemical reaction, remember, is that we use numbers called coefficients. Okay, those are those big numbers that we put in front of the compounds and elements that are in a chemical reaction. Okay, we never change the little numbers in a chemical reaction in order to make things balance. Right? The reason for that is that if we change those numbers, we actually change the stuff we're dealing with, and that's not how you balance a reaction. All right? And then lastly, understand the law of conservation of matter. Okay? Matter cannot be created, and it cannot be destroyed. Okay? It can be changed, it can be altered, whatever, but you're always going to have the same amount of matter you started with. Okay? Questions on any of that? Everyone's good with that? Okay. All right. Law of conservation of mass. Mass has to be conserved in reactions because matter can't be created, it can't be destroyed. Okay, since all matter has mass, the mass of the reactants equals the mass of the products. Okay, all matter has mass, whether it's a solid, whether it's a liquid, whether it's a gas. Okay, all matter has mass. All right, but a lot of people seem to think for some reason that gases don't have any mass because they just float around. We don't feel them. Is that true? No. Okay, we just don't. We feel the pressure and the mass of the atmosphere. We just don't notice it. Okay? Our brain just kind of turns off the stimulation. All right? But do you notice when the amount of atmosphere above you or below you changes? What happens? Your ears pop. Okay? Atmospheric pressure, okay, is essentially based on how much weight of the atmosphere is above you. All right, so as you go up or down rapidly, your ears might pop because there's a change in pressure because there's more or less mass of air above you pushing on your eardrums. Everyone follow me on that? Okay, that's why if you go out into space without a spacesuit, you pop. Okay, the weight of the atmosphere is what keeps all of the gases that are normally dissolved in your blood and not turning into little bubbles that will eventually find their way out. Okay, that would be a pretty bad way to go. Okay, right up there with like inhaling molten rock. Okay, yeah, something like that. Not such a good way to go. All right, so the weight of the atmosphere pushing on us is the way we know that gases have weight. The other way, okay, take a car tire and let the air out of it. Make sure it's yours and that you have something to inflate it again with. Don't do it as a prank. Okay? Let the air out of it completely. Okay? As much as you can, pick it up. Okay? Then reinflate it. I guarantee you, when you have it inflated, it is heavier. Right? A tire has a lot of air inside of it, okay, and it would be noticeably heavier to pick up when inflated versus deflated. All right, you don't notice it so much with like a volleyball or a basketball or football because there's not that much air in there, okay, but something heavier, okay, bigger, you would certainly notice it. Yes. Not noticeably so, like not to us, picking it up, but okay, yes, it would be heavier. All right, now, if you filled it with helium, it's still heavier, but if you tried to put it on a scale and weigh it, it wouldn't register as heavier because it would be buoyant and be trying to leave, right? Okay, so if we're looking at this reaction here where we're forming water by reacting hydrogen gas, okay, with oxygen gas, we can see that on this side there are 4 hydrogen atoms, and on this side there are 4 hydrogen atoms. On this side, there's 2 oxygen and 2 oxygen. So we've balanced that reaction. We've obeyed the law of conservation of mass. Okay, there's the same amount of everything on both sides. All right. In this picture here, which one of the ones on the bottom is showing the correct situation where the law of conservation of mass has been obeyed? B? Okay. So what we got to look at here is how many red ones are there in B? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, up here there's 2, 4, 6, 8, 10. All right, and there's 1, 2, 3, 4, 5 yellow ones. 1, 2, 3, 4, nope. Okay, it's too much yellow in this top one. All right, which one of these is showing the law of conservation of mass being obeyed? D. Okay, in D there's 2, 4, 6, 8, 10 red, and there's 1, 2, 3, 4, 5, 6, 7, 8 yellow. Okay, and there's 8 yellow up here. Everybody follow me there? All right, so in this one here, yes, we've had a chemical reaction occur, and we have the same amount of product as we had reactant. Okay. All right, so that's what the law of conservation of mass is. Could that be a multiple choice type question? What do you think? Yeah, that's a pretty easy multiple choice question. Okay. Okay, when we're balancing, right, we've talked about these steps already. Okay, when you're balancing a chemical reaction or chemical equation, okay, you write the chemical formula for everything. Okay, you don't have to include the state of matter. All right, you may have seen that on that first worksheet I gave you. Okay, that it has like little G's and little S's and L's and AQs beside some of the stuff. Okay, that's just telling you what state it's in. And actually, in Science 10, that doesn't matter at all. Okay, in fact, you very rarely have to deal with that even in Chem 20. All right, but by Chem 30, you'll deal with it quite a bit. All right. For step 2, we always said try balancing the atom or ion present in the greatest number. That's always the best one to start with, unless it happens to be oxygen. Okay. You always want to, for some reason, do oxygen last, because if you do it first, you just end up doing it over again. All right? Don't ask me why. It's just the way it seems to work. Okay. Step 3, repeat step 2 and balance each of the remaining atoms and ions. And then fourthly, double check and make sure you haven't made a mistake anywhere along the way. All right? Those are the steps that we went through. Now, we did say, however, that combustion reactions had a separate set of rules. All right? What were the 2 rules we had to remember for a combustion reaction? What order do we balance them in? Alphabetical. All right, so maybe we'll just make a quick note down here. Okay. Okay, combustion balancing rules. Okay, rule number 1 is balance alphabetically. Okay, so that means C, then H, then O, right? And the second rule is what I call the rule of 2. Okay? Okay, so rule of 2, okay, if there's an even number of carbon atoms, okay, then you must start the equation with a 2 coefficient. All right, what I mean by that is if I had, let's say, C2H6 plus O2, okay, going to CO2 and water, okay, as soon as I see that there's an even number of carbons, I put a 2 here to start with, okay, and then I start balancing alphabetically after. Okay, how many people are done the worksheets that I gave out the other day? Okay, all right, I thought there might be a few done, but there's, okay, seems like most of us still have a little bit to do on those. All right, can I take this off now? All right, so the example here, guys, okay, so we've got copper wire immersed in a solution of silver nitrate. Now, you haven't got any like this question yet, okay, where I give you the question in words. All right, it makes it a little bit tougher because now you have to make sure you get the formulas right when you write them out. All right, so it's a little another kind of step forward. All we've had so far, okay, is essentially the reaction is already written for you in formula form. You don't have to worry too much about it. Okay, but here is why you've got to be able to write your formulas correctly. So it says copper wire is immersed in a solution of silver nitrate. A single replacement reaction occurs. All right, so I write out Cu as an element, silver nitrate, AgNO3, this is +1, that's -1, so that's okay. And a single replacement reaction means that silver will get replaced by copper, because in a single replacement reaction, metals would replace each other or non-metals would replace each other. All right, so silver ends up by itself, copper ends up with nitrate. Okay, copper's most common charge is 2. Okay, nitrate is -1, so when we drop and swap, we end up with CuNO3 2. All right, so now I've got all the stuff written out correctly. Okay, nitrate, okay, is the thing present in the largest number. So we're saying balance the nitrate ions first. All right, so on this side there are 2. Over here there's only 1, so I put a 2 here. Okay, everybody follow me there? When I put that 2 there, that gives me how many silver? 2. So my next step is I got to put a 2 in front of the silver. Right? And then double check that my coppers are still 1 and 1, and now the whole reaction is balanced. Okay? Everybody with me there? I mean, we've been doing that for a couple of days already. Okay? It's just kind of a review on how to do that. All right. Okay, a reminder, okay, polyatomic ions are balanced as a single unit, okay, not as individual atoms. You may want to add to that unless they what we call dissociate. Okay, that means break up. Okay, so if nitrate were to break up in the reaction and you had NO3 on one side, but on the other side you had NO2 and then another O, okay, that's a dissociation. You'd have to balance them element by element then. All right, it doesn't happen very often in Science 10, so it's not something you'll deal with. All right, now this is the next thing we're going to get to. We're not going to get to it right now, okay? But the next thing we're going to get to is predicting the products of a chemical reaction. But I want to make sure we get through, okay, that first worksheet before we move on to that. Okay, so take out those worksheets that I gave you the other day. I'm going to give you about another 15 minutes or so to work on those, and then I'm going to start talking about the next step. Okay. Now, here's the next thing that we're going to be doing. Okay, we're going to be predicting what the products of a chemical reaction are. The most important part of being able to do that is being able to identify what kind of reaction is going on just from the reactants. All right, and we can do that because all the reaction types that we've looked at all start differently. All right, so what we have to be able to do is identify what kind of reaction is going on from only half of the reaction. Once we know what kind of reaction is going on, we know what pattern to apply to the reaction to figure out what will be on the other side. Now, there's a couple of other challenges that go along with that. Once you figure out who goes with who, you also have to figure out, do I need swap and drops? Are any of those the special highlighted elements, okay, that are on my periodic table, and I have to remember that they're an 8 when they're by themselves or a 2 when they're by themselves, okay, and all of those kinds of things. It's not especially difficult. It's just there's a little bit more to think about because it's not just being outright given to you. All right? So let's say for number 1 here, okay, the first thing we need to do, the first step, is identify what kind of reaction is going on. What kind of reaction starts out with an element reacting with another element? It's a synthesis reaction. Okay, in a synthesis reaction, these two elements are going to do what? They're going to go together to form a single compound. All right, so all I have to do then is put them together over here, Ca and O. Now, is that an ionic compound or a molecular compound? It's ionic. It's got a metal and a non-metal. So then I got to double check and make sure this formula is right. Calcium is a +2. Oxygen is a -2. Okay, so does this compound work out? Yeah, when I swap and drop, these things just cancel. All right, now I've got my products predicted. Now what do I have to do with that chemical reaction? I got to balance it. Okay, on this side, calcium is already balanced, but oxygen is not, so I have to go with oxygen. There's 2 over here, so I need a 2 here. That gives me 2 calcium, so I need a 2 there. Everybody follow? Okay, so you have to identify the kind of reaction that's going on and then figure out who ends up with who and in what order on the other side. Okay, so for number 2 here, what kind of reaction is going on? Alex? Simple decomposition. The only kind of reaction that starts out with only one reactant is the one where it breaks down into something else. All right, so this is going to break down into its 2 parts, magnesium and sulfur. Are either of those highlighted on your periodic table? Sulfur is, okay? Sulfur is highlighted because when it is by itself, it comes in sets of 8. All right, that's why it's highlighted on your periodic table, right? So if you look at it, I think it's highlighted in what, orange? Or yeah, okay, so it's highlighted in orange, and you'll see on the top of your periodic table it says orange equals octuplets or something like that, okay? So sulfur, when it's by itself, always comes in sets of 8. Magnesium, not special. We're not trying to hurt its feelings, it's just not, okay? So there's only one of it here, okay, but there's 8 sulfurs. How many do I have here? 1. So what needs to go in front of this? An 8. Okay, that gives me how many magnesium? 8. Okay, and now the reaction is balanced. Okay, does that make sense? All right, in number 3, what kind of reaction is that? Nope. Drew, or Dom? It's a combustion reaction. Okay? Anytime you have carbon, hydrogen, and oxygen all on the same side, it's a combustion reaction. All right? So in this case, this stuff is propane. Okay? Propane burning in the presence of oxygen. What's always the products of a combustion reaction? Carbon dioxide and water. That's just one you're going to have to memorize. You don't have to do any thinking, okay, with combustion reactions. Doesn't matter what these numbers are, the products are always CO2 and water. Always. Okay. Special balancing rules for combustion reactions. Balance in alphabetical order and rule of 2. Does rule of 2 apply on this one? Okay, I have an odd number of carbons, so I don't need to put a 2 in front of this. Okay, there's 3 carbons here, so what needs to go here? 3. Okay, there's how many hydrogen here? 8. So what times 2 will give me 8? 4. Okay, 3 times 2 oxygens is 6, plus 4 more oxygens is 10. What times 2 gives me 10? Okay, and now that one's balanced. Right? It's really not a lot different than what we were doing, except you don't have the products this time, but the balancing works the same. Okay? What if you can't make it balance? What if no matter what you do, you can't get a reaction that you've predicted to balance? What does it tell you? Well, not that it's not a reaction, but chances are you messed something up. Okay? If you can't make it balance, chances are a swap and drop hasn't been done correctly, or one of your products just isn't right. Okay? So if you can't make it balance, you need to go back and have a look at it and see if you made a mistake somewhere when you matched things up. All right. What kind of reaction is going on in number 4? Yeah, double replacement. Okay, so we got 2 ionic compounds, and it's a double replacement reaction. In a double replacement reaction, okay, the metals switch places. Hydrogen is acting as a metal here because it's listed first. All right, so that means hydrogen's new partner is going to be who? Okay, can it go with sodium? Can 2 metals end up together? No. Okay, so hydrogen has to end up with OH. So hydrogen's new partner is OH. Okay, who's sodium's new partner? Chlorine, because that's all that's left. Okay, this is a strong acid. This is a strong base. So it's an acid-base reaction. Whenever you mix an acid and a base, you get water and a salt. Okay, it may not always be salt, okay, but it'll always be an ionic compound and water. All right, now I need to balance. Done. How do I know it's already balanced? Right, there's no little numbers. Everything is a 1. Okay, is this sort of making a little bit of sense here? Okay, the big thing is that you got to be able to identify the type of reaction that's going on. Once you do that, you can even look back in your notes, okay, in class and figure out what kind of reaction is, or what should probably go together. Now, the other thing I have here, and I will go and get it for you off the photocopier, is this flow chart. Okay, and you can use that for a little while, but don't get too used to it. I don't want it to become a crutch, because I'm mean, and on an exam, I'll kick that crutch out from under you and not let you have that. Okay? So it's okay until you kind of get the hang of how to do it and then try and throw it away. All right? So first step, write out your reactants. okay, your reactants, the starting materials, swap and drop any ionic compounds and check for special molecular elements. So if your reaction has two elements, let's say sodium and chlorine, okay, then you're looking at a synthesis reaction. Okay, you put the elements together into a compound, metal, then non-metal, okay, and balance. Okay, is that pretty straightforward for following? Okay, if you have only one compound, so NH3, then you have a decomposition reaction. Okay, split the compound, write the elements separately, check for special molecular elements like nitrogen or hydrogen or oxygen, whatever, and then balance. Okay, if you have any combination of carbon, hydrogen reacting with oxygen, you got a combustion reaction. Okay, products are always CO2 and water. Okay, that's H2O there. Okay, balance in alphabetical order. Okay, and the rule of two is also written in there. Balance. Okay, if you got one element and one ionic compound, you have a single replacement reaction. Okay, look at the lone element, identify if it is a metal or a non-metal, and then replace appropriately. So if it's a non-metal, you replace the non-metal in the compound. If it's a metal, you replace the metal in the compound with it. Okay, and then swap and drop your new ionic compounds. Okay, look for special elements and balance, and then double replacement, similar. Swap the metals, swap and drop your new compounds, balance the reaction. All right, everybody with me there? Okay, it's going to take a little bit of practice, and that's okay. We've still got tomorrow where we're going to practice. Thursday and Friday, we'll actually be in the computer lab working on the research project for this unit. Okay, so you got a few things coming up here, and then probably on Monday, we'll do the lab to do with reactions. Okay, so we'll have another lab coming up here. All right. Okay, listen up here, guys. All right, on the worksheets that you have in front of you now, okay, the first one here starts out with these balancing items, okay. 6 and 7 you don't have to classify because they're beyond the reaction types we do in Science 10. I just put them on there because sometimes people get, you know, overconfident, maybe a little cocky with their ability to do balancing. So if you feel you need to be humbled, okay, do those ones. They're not that hard, but you do have to think quite a bit more because a lot of things split up, and tracking where everything goes is a little tougher on 6 and 7. You don't have to do 6 and 7. I would never give you a reaction like 6 or 7, okay? But understand that you can still do those if you want. Okay? For these other ones here, okay, we're predicting the products and balancing any that require it. Okay? And the other sheet you have, okay, is not this one, it's a different one. Okay, you might actually want to start with the other one unless you really want to try the prediction stuff first. Okay, so for number 1 here, just to show you what goes on. Okay, potassium is added to water. Symbol for potassium is K. All right, water you can write as HOH or you can write it as H2O. It doesn't matter which way you do it. Okay, but the answers are slightly different. Both would be right. Okay, in a single replacement reaction, potassium is a metal. So who is it going to replace here? Hydrogen or hydroxide? Hydrogen, because hydrogen is acting as the metal here. So that means K ends up with OH, and hydrogen ends up by itself. Now it says on the flow chart that I still haven't got to you, it may have to be tomorrow now, okay, that the next thing you're supposed to do is swap and drop your compounds. All right, well this is -1, this is +1, so that compound's okay. And then check for any special molecular elements. Is hydrogen highlighted on your periodic table? It comes as a 2 when it is by itself. All right, so now that we have that, now we can start balancing. There's 2 hydrogens over here. How many here? 1. Because this hydrogen stays with oxygen. So I need to put a 2 here. Now that gives me 2 hydroxides. So I need a 2 here. That gives me 2 potassium. So I need a 2 here. Your other option on that one would be if you went K plus H2O. Okay, well then you switch it differently and you end up with K2O plus H2, and the balancing ends up being like so. All right, there's 2 ways to do that one. All right, either one would be acceptable. So that's what you're doing for that one. Write it out in formula form, predict the products, balance it. Okay. All right. Questions there? All right. So you got about 10 more minutes. Okay. We can work on those, and that's what we'll be working on tomorrow. I'll go through a few more examples at the beginning of class tomorrow. Okay, just to kind of refresh everybody.